Yeah. Okay, cool. This is a slightly weird talk for me because obviously it's at our gaff. So a load of my current co-workers have shown up who've never seen me speak, so that's already a bit nerve-wracking. HR are looking at me through that plate glass window right now. Not only that, but a whole bunch of my workmates from my last gig have shown up. So it's a bit like you throw a house party and your mum and all your exes like descend at once. Like it's a lot of performance anxiety. So perhaps resultingly, I'm not going to do a very technical talk. I'm going to talk more about the kind of the business case for serverless. So if you came here expecting a really technical deep dive on Lambda and now you're disappointed, the exits are over there. But there will be another talk after mine. I think it'll be a lot better. So the title of my talk is Why So Serverless, which is a great pun, I think, although I can't take any credit for it. I am Bob. You can find me on Twitter as Bob the Mighty. Slides usually end up on GitHub as GitHub Bob the Mighty. So I guess before we can talk about why Cazoo adopted serverless, we need to get onto the same page about what serverless actually is, right? So this is a Wardley map. Has anyone seen these before? Yeah, a few of you. So these are a way of visualizing a high-level depiction of a situation, right? And the guy who came up with these is a guy called Simon Wardley, who's a weird guy who was the director of strategy for cloud at Canonical around the time that Canonical became completely ubiquitous with Ubuntu on kind of cloud servers, right? So he knows what he's talking about. And this particular map shows how, in his opinion, the desire for a low mean time to recovery, itself driven by a need to experiment, will inevitably drive organizations towards serverless, right? Which is something I agree with, and I'm going to try to convince you of that over the next 20 odd minutes, depending on how fast I talk. So this is a quick summary of my journey towards serverless architectures. In my first job in 1999, I worked on an industrial estate in Duckmanton at a startup. We made a CMS, a content management system for small businesses who wanted to make like their own websites. And the server was literally underneath the boss's desk. It was a Pentium 3, I think, with an ISDN modem that had like 100 kilobytes upstream rate. And we served all of our customers' websites on this one box with no backups. We also had our databases, which were Microsoft Access, which was fun, and all of our source code, because what's source control? So that was cool. My next job after that was for a company that ran sales and management training for automotive dealerships. And now the servers were in a cupboard, so it was a bit more serverless, because at least I couldn't accidentally kick the server on my way past to make a coffee. And I'm fairly sure we had more than one of them, because it was quite a big cupboard. But if we needed a new server, realistically, it would have taken the boss like a couple of months to get all the bits and build it on the desk and stick it in the cupboard and all the rest of it, right? Then I worked for a while for an ISP called Pipex. I ran the Windows web hosting team over there. And being an ISP, they actually had quite a lot of servers, but they were further away, right? They were managed by a separate team of ultra nerds in a data center close by. And we could serve about 10,000 customer websites off one box. And getting a new one would have taken, like maybe 3-4 weeks set up. Around 2008, I was working at yet another startup. This time we were hosting with Rackspace, who had an amazing managed service. So it was like the ultra nerds, but kind of now outside the company, where they would monitor your servers and back them up and generally sort them all out for you. And they could set up a server in maybe a couple of weeks, couple of weeks, after we'd given them a phone and said, please can we have another server? And then in 2015, the cloud happened, and I started working properly with Amazon, right? And after a lot of hard work and using infrastructure as code and all of that stuff, we got the time it takes to provision the server down to about 2 minutes, which is an extraordinary feat. And in fact, the guy responsible for it is sat over there, and he did an amazing job to make that happen. And that still amazes me, right? That we can get a brand new server hot off the press in 2 minutes. Latterly, of course, I'm working at Cazoo, where we have no servers at all, right? Just these Lambda things, whatever the hell they are. And they take under a second to spin up on demand as our traffic patterns shift throughout the day. And at each point in this journey, the servers became physically further away, but also conceptually further away, right? In my first job, I had to literally copy files from my computer to the source control on the server, go and edit some settings in IIS to make things appear on the internet, right? At Cazoo, we just express our deployments as a computer program, right? We just say what kind of resources we want, and they appear as though by magic. And at no point in this journey was I specifically aiming for serverless, right? That wasn't the intent. But at every step, I was trying to get cheaper, more reliable, faster compute. And inevitably, as Simon Wardley predicts, we were driven towards this kind of serverless destination. So serverless, Wardley talks a lot about strategy and how we produce it. And one of his terms of art is doctrine, right? And a doctrine is a set of operating principles that we can apply to novel situations in order to get answers. So under Wardley's model, the serverless is a doctrine. And the serverless doctrine is this, right? I don't want to run it if you can run it better for me, because that way I'm free to think about the things that actually matter to my organization. How do we know what's important to the organization? Well, this is a product alignment matrix. Anyone who's worked with me before has probably seen one of these. I was taught to use these when we were hosting on Rackspace. And the idea is that we can plot out the stuff that we do as an organization into this two-dimensional space, right? So on the x-axis is mission criticality, right? Over here on the right is stuff that if you don't do, you don't have a business. And over here on the left is stuff that if you don't do, no one gives a damn, right? So accounting goes over here. If you don't do accounting, the CEO goes to jail, and that's a bad thing. Whereas, I don't know, maybe, horrible as it sounds, maybe like, you know, the charity payment scheme that we run at Cazoo goes over here somewhere. It's not critical, we could stop doing it, right? On the y-axis is business differentiation. So up at the top is stuff that makes us a unique and special snowflake as an organization. The stuff where only a handful of companies in the world do it. And on the bottom is the stuff that everybody does. And we can use this to inform our technology choices. So stuff that is critical and boring, we should buy off the shelf, right? For example, credit card processing. Do not build your own credit card processor. It's very boring, and if you get it wrong, the CEO will go to jail, right? So use Stripe, right? Just buy it off the shelf. It goes in this bottom right corner. Stuff that is differentiating but not critical goes up here in the partner box, right? For example, we could build an app where we show you 20 cars and you swipe left and right, and at the end we tell you what your perfect match is. It would be a bit of harmless fun. It might get us a write-up in the Daily Mail or in the Metro or whatever, drive some traffic, but it's fluff, right? Outsource it, it doesn't matter. Don't waste your time. Stuff that isn't critical or differentiating goes in the stop box, right? For example, we've had a bunch of conversations at Cazoo about voucher codes. Realistically, we don't think they will drive enough revenue to be critical, and they're not interesting enough really to drive traffic. So right now they live down here, right? That leaves this box, this blue box marked build. And this is the stuff that is both critical and differentiating. This is your core domain, right? This is where you build fancy code and you do TDD and BDD and DDD and DDDD and all that stuff, right? It's where you put all of your hard work and your fancy engineers and your architects and software craftsmanship and all of that, right? That's the stuff that's important. So let's try this out. Things we do as an organization. Well, we take payments, right? We've talked about that. So that goes in the bottom right. But so do a bunch of other things, right? Like add to basket, user analytics, the FAQ. 95% of running an e-commerce website is boring, off-the-shelf crap that goes down here. What about delivering cars to your house, right? That's upper right. Auto Trader won't do that, and neither will the dealership at the end of your road, right? Going out to auction and buying thousands of cars a month, refurbishing those cars, figuring out what kind of pricing we should apply to used cars based on fancy machine learning models, that stuff is mission critical and completely differentiating, right? No one else does it. That's what gives us an edge over our competitors. What about hosting a website, right? Where does that go? I mean, does that give us an edge? I mean, it's critical, but it's 100% boring and off the shelf. What about monitoring or patching servers, right? In my last job, the EC2 one, we ran a bunch of Elasticsearch clusters and a monitoring tool I introduced called Riemann that you had to like configure in Clojure. I'm sorry. And we had like a Docker cluster running HashiCorp Nomad and a distributed config system with console and like a clever caching and routing engine built in HA proxy. And it was cool, but all of it, absolutely all of it, is bottom right, boring crap that you shouldn't have to care about, right? All that fancy DevOps tooling that you guys are so excited about is bottom right crap. In 2020, if you're even thinking about deploying your own Kubernetes cluster, you are living the bottom right dream. So there is an ongoing war in the serverless community. There's an ongoing war in the serverless community about what to call ourselves, right? A lot of very smart people who are extremely online don't like the term serverless because they think it puts the emphasis on the wrong bit, right? It's not that we don't have servers. That's not what's important. Having no servers is a consequence of the doctrine. Really, we need to think about consuming services. We need to think about relying on third-party services to do as much of the heavy lifting as possible, right? With Lambda, I just care about writing my domain logic, and then I give it to someone else to run, right? And I don't have to think about any of that stuff. There's entire classes of tools that I no longer need to give a damn about. Log aggregation, you can use CloudWatch. Routing and discovery, use API Gateway. File storage, use S3. All of these problems are really hard and they're solved for 99% of production workloads. You never have to think about them again, so long as you're willing to architect around their constraints. So this is a context diagram I made of Cazoo a while back. It doesn't matter if you can't see the text. Whilst we were discussing micro front ends, right? And what we see is 3 systems that provide different bits of a front-end journey, right? So there's like the checkout process where you buy stuff, and search and browse where you look at cars, and like content where we show you like reviews or that kind of irritatingly twee prose you find on the back of soft drink bottles, that stuff. And each one of these 3 systems is connected to another external service, right? So we've got a headless CMS, we've got a headless search engine, we've got a headless e-commerce platform, and my bet is that over time, your architectures will increasingly look like this, right? Each one of these is just a bunch of lambdas and maybe a dynamo table, and that's it. All we're really doing is providing the glue to customize these domains to our specific requirements. Because if you don't do this, and you spend all of your time on that stuff in the bottom right, your competitors are going to blow right past you whilst you're spending years figuring out how to build these, which you don't need to do. In fact, there's entire classes of application which over the next few years, you won't need to write any code at all. For example, right, here's a random crappy diagram for which I apologize. So in this system, when I upload a file to this S3 bucket, we raise a notification, that goes onto a queue. We run a third-party Lambda that extracts text. We put that text onto a queue. We run another third-party Lambda that does sentiment analysis. And then we have an event bridge rule that says, if the result of that is negative, send me a Slack message. And I could conceivably today build this entire thing with nothing but configuration, no code required. And I think that over time, we'll start to see more and more of this stuff, right? We're going to reduce the plumbing to an hour's worth of Googling and writing some Terraform scripts, and that's it. And some of that will sound boring, but it should be. This is boring, bottom right crap that you shouldn't have to care about, right? That's where we're headed. So, when we started at Cazoo, I had a pretty clear idea in my head that we were going to adopt serverless as a doctrine. And when you start something new, you get the opportunity to make kind of long bets. So my long bet for Cazoo was that we were going to adopt AWS Lambda as our primary deployment target. How many people here are actually running serverless in production? A few of you. Okay, then this next bit's like probably a waste of time. I'm going to do it anyway because I have to go through the slides. It's going to be complicated, right? So this is how to serverless in 5 minutes. Step 1, choose an appropriate language. So as a recovering .NET programmer, it gives me no pleasure to report that big runtime languages like .NET and Java suck for wide classes of serverless applications because the startup time will kill you, right? We use TypeScript because I'm a hipster. It's kind of going okay. I'm not wedded to it. I actually think that PHP might be the perfect language for serverless. because the model of a single process for each request response pair is exactly how Lambda works, but can't tell anyone I said that or they won't invite me to architecture conferences anymore, right? But I do expect to see officially supported PHP runtimes later this year. Step 2, you need to choose a framework. If you're going to build serverless applications, you do not, under any circumstances, write it all from scratch by hand. I occasionally meet people who do this, and they say, yeah, we just run a grunt build, and then we copy the deployment zip file, and we stick it in the console, and we configure it all manually. I respect those people, but I respect them like you respect the dangerous-looking guy on the tube late at night, right? I respect them like you respect heights, right? Those people are dangerous and not to be messed with. If you try and build your own Lambda deployment story, you're going to have a bad time, so don't do it. Cazoo, we use a serverless framework from serverless.com. And that's a kind of simple YAML-driven framework for configuring like all the stuff you need around the edges. They're building a bunch of kind of continuous deployment tooling and logging and monitoring solutions that's now really rough and ready. But maybe in 12 to 18 months, you'll be able to define your entire CI/CD pipeline, logging and monitoring, application stack in a single YAML file and have it work. And that's going to be awesome. Step 3, define boundaries. I speak to a lot of people who think that a function is a microservice. It's not. No, stop saying that. Practically, your services will have a bunch of functions in them, and that's okay. I'm going to show you in a second a made-up service for managing a customer's cart. I'll do it now, why not? Can I do this? Wicked. Everything is working perfectly, except that my terminal has just crashed. That's okay. We can recover this. We're going to open up another one.
You use a Microsoft virtual machine.
I'm going to pretend you didn't say that, man. Okay, let's close this. Force quit. Smooth. Okay, cool, man. Kitty, let's do that. Ignore that, I don't care, everything's fine. And we're going to CD back to the directory where we were, which was in code, play serverless from scratch, and 03, add to cart, and we're going to run Emacs because I'm a hipster. And we're going to bigify so that you guys can see maybe. So, where was I? Yes, so I'm going to quickly show you a serverless application. It's a very simple one. We use this for teaching at Cazoo. So we've got here a simple JavaScript module where we define like a model for talking to DynamoDB. Is that big enough? Should I make it bigger? Maybe that's slightly bigger. Is that better? Yeah, so we've got a model. It's like just an ORM model. Got a couple of functions, one for setting the quantity available in a user shopping cart, one just for getting the cart. And then we map that to Lambda in a separate module here. So these are the actual Lambda event handlers. A request comes in from the internet. It's one of these things, and then we just invoke that service. Splitting it that way, so splitting out like the Lambda invocation part from the service just makes it a bit easier to test and to reason about. And then lastly, we've got a YAML file, as promised. It looks like this. So here's my service. It's called Bob's Cart Service because I've got no imagination. And then I'm binding those functions in that handler module to HTTP events, right? So that's cool. I've got 2 JavaScript files, 1 YAML file. And in theory, if I go to here and I type SLS deploy, and everybody crosses their fingers. So what's going to happen now is that serverless in the background is going to package up my JavaScript. It's going to get rid of all my development dependencies, all of that stuff, produce me a bundle, zip it up, upload it, and then I'm going to have to authenticate. Just talk amongst yourselves. So in the background, that's going to go away. Once I tell it to do it again, it'll do. You're all jealous of my amazing IAM setup, I know. So that's going to go away, and in the background, that's going to create me a CloudFormation stack, right? So it's using Amazon's own infrastructure as a code stuff, but it's kind of working at a higher level of abstraction. And the nice thing about that is it's going to hide from me all that complexity, and when it's done, it's going to give me back with a bit of luck and the grace of God, it's going to give me back a URI where I can invoke that function. If I call that URI, Amazon are going to bill me in 100 millisecond units for running my code. If I don't call that URI, they are never going to charge me a penny. That's it. That's how we deploy software in 2020. So we did that bit, and we did that bit, so ignore that. So, last bit, how's it all going? So I want to end by talking how this has actually worked out for Cazoo, because there's a lot of rough edges still in serverless, and I know people get kind of nervous about like the billing and managing complex applications and all of that stuff. So as Ian kind of alluded to, in October last year, we launched a public beta, right? When we started building properly in August 2019, right? So in other words, we built and deployed systems, gathered the data for putting a vehicle on a website, let you search and browse our stock, buy a car, cash, and deliver it to your house in 90 odd days from start to finish. And in fairness, we almost killed Ian. So I'm not recommending that you do this, but it goes to show what you can actually achieve if you stop doing all the stuff in the bottom right and just focus on the top right. So we run a boot camp at Cazoo so that we can kind of indoctrinate new starters with the Cazoo way. And as part of that, we do a serverless workshop where we build and deploy basically that app. And we've had non-technical attendees quite often, like the CTO. But we get people come along who've never used Git. They don't have any SSH key installed. By the end of a 2-hour session, they're able to deploy that application, look at the logs, look inside Dynamo databases, see metrics, and understand vaguely kind of what's going on, right? So in March when I started, there were 2 engineers. And by October, there are about 40. And I have no idea how we would have scaled the technology team that fast to 9, 6, whatever it was, autonomous squads of developers if it weren't that simple to build and deploy software. And across our environments, we now have deployed around 10,000 separate resources, most of which are completely transparent to our developers. They've got no idea we've got 10,000 things because they don't have to think about it. And of the 60 engineers currently working at Cazoo, 0 are full-time ops people. A couple of weeks ago, we launched our first TV ad campaigns. Has anybody seen these yet? Yeah, I'm sorry. And so traffic was okay to the website before the ads. We've been doing pretty well just off kind of word of mouth and the billboards and things. And we were serving maybe 200 or 300 pages a minute. So on a Node.js application, which we've got, it's kind of I/O bound. I could probably do that on a T2 small, T2 medium. I'd want a pair of them for redundancy, so that's fine. Stick it behind a load balancer. So realistically, like a couple of small or medium EC2 instances, a load balancer, everything's fine. It's not heavy traffic by any means, but it was respectable, right, for a startup at this stage of growth. So here's what happened when the ads went live. Within 90 seconds, traffic increased by 2 orders of magnitude, right? Down here, we're doing around 5, 6 requests a second. Up here, we're doing 500 odd requests per second, right? So the EC2 setup I described earlier, where we spent 4 or 5 years getting it to the point where we could scale a box in 2 minutes. By the 2-minute mark, the load was over. People had come to the website, gone, oh, that's cool, and gone off again, right? How many servers do I need to run if I want to handle 2 orders of magnitude more traffic without service degradation? So here's our latency and error rates for another ad break a bit earlier. You'll note the number of 404s goes up in line with traffic, but the number of 500s is 0. So we had 500 requests a second out of nowhere, and we did not drop a single request. You'll notice also that latency throughout this period is flat. If anything, it goes down slightly. So I couldn't have done that with EC2. I definitely couldn't have done that with Rackspace. And it's not even worth asking if it were possible to do that with the boss's server under his desk on an industrial park in Duckmanton. There's one last cool thing I want to show you, and then we'll do questions and things. So Lambda, you might remember, is metered pay per use, right? You pay for compute time. Each invocation of a Lambda function is billed for the number of milliseconds it runs and the amount of RAM that we allocated. There's some subtlety in there in the more RAM you give it, the more CPU it gets. So you've got this one dial for going faster and slower. This bar chart shows our build units over time, right? So how much it was costing us per minute to run Lambda. You can see where the TV ad happened because there's a massive spike, right? So if we round up to hourly, you can see the difference, right? So if we look at the difference between this hour, between 6 and 7, and this hour, between 7 and 8, we can do a quick bit of back of a fag packet maths and work out roughly how much it cost us to service that TV ad spike, right? So if you get the numbers off the billing calculator and stick it all in and carry the 1 and plus, you get 83 cents, right? In conclusion, serverless avoids operational complexity, which made it possible for us to spin up 9 squads of engineers in about 6 months, working autonomously, deploying multiple times per day to production, building an online dealership in about 3 months. Serverless scales elastically with such extraordinary efficiency that we could increase traffic by 2 orders of magnitude in under 2 minutes and not skip a beat. And serverless is cheap if you build around its constraints, because our entire business costs about $8 per day in compute time. And that's it. Well, I have nothing more to say. Yeah, so the question is, how would we use a kind of a standard framework in serverless? The answer is I wouldn't. I'm not a big framework guy at the best of times, right? If you wanted to use a framework with Python, there's something like Chalice, which is built specifically for that use case, right? But I think you're going to find pain trying to take a big framework, squeeze it into a tiny box. It's just not the right tool for the job.
Is that purely because the package is too big? Or?
It's partly that. It's also kind of the operational assumptions that those frameworks run under, right? So you need to move to a model where you're working in terms of very fine-grained use cases that are stateless and scale horizontally, rather than I've got a server that's running some stuff over a long period of time. And that is a different paradigm. You do have to architect around those constraints. You have to make that a first-class concern. The question is, how do we mitigate cold starting? And the answer is we don't care. If you look at our P95 latency, there's occasional spikes. Maybe someone will come to the website and the page will render in 2 seconds instead of 1. It's not the end of the world. Because we're using TypeScript and it's fast, you can use provisioned concurrency now. So you can pay money for AWS to keep a bunch of instances warm for you, and that should mitigate that tail latency if it is an issue. The other thing you can do is use caching. So we have Cloudflare running as a CDN. We now have a teeny tiny cache hit ratio for dynamic pages. We want to see that go up to 90-odd%. Then it doesn't really matter, right? Like most people are just going to get straight out cache. So the question is, what do we do with the stuff that isn't domain model? But I don't understand the question. Could you give me an example?
What are your customers actually interacting with? Is it purely an app, like your website kind of?
Yeah, okay. So the question is, so like the website stuff. So we use Next.js, which will be familiar to you, I'm sure. Next.js has support for rendering to serverless functions. So you can do serverless side rendering, as they call it. I hate that term. You can do serverless side rendering, so just like you would normally. But in general, it's not really any different to building any other website. I mean, you need to structure your application differently, but fundamentally, you've got a web endpoint that's going to give you back HTML. Yeah, so the question is, how do you handle long-running functions? At the moment, there really aren't any, because you sort of need to build around that constraint, right? So the data team, for example, do some stuff that runs longer than I would like. The maximum time I think you can run a Lambda function for is 15 minutes before it will time out and die. But realistically, if you're up to that point, you want to look at other options. Probably the next step down in that kind of serverless spectrum is Fargate, which is pay-per-use Docker containers. So it's a bit more overhead than Lambda, but not by a huge amount, in all honesty. So the question is microservices versus serverless and how do they map? So as it happens, I'm going to be giving a talk next week at the Serverless London meetup about exactly this topic. But so in the olden days, we used to talk about business capabilities and autonomous components, right? So you have a business capability, which is like a service boundary. So a thing that the organization does that you need to support with software. But within that business capability, you have multiple things you deploy, right? Maybe you've got an API and an event listener and a database. Those things form part of the same service. In function as a service, I like to think of functions as autonomous components. I could deploy one of them if I wanted to. Realistically, I'm going to deploy the whole lot because they form a single deployment boundary, because it's a single business contract boundary that I'm worrying about. Does that make sense? Yeah. How do I confidently know the whole thing is working end to end? Right now, I don't. I'm going to assume that if it weren't, someone would be shouting at me. But what we want to do is, if you've got more questions about it, the lady at the back is Nicola, who's hiding behind a Coke can. But she can give you more details. What we want to do is to support synthetic transactions at every part of that, in every one of those services. So then we can drive realistic journeys where you actually buy a car, actually take out finance, actually arrange delivery, but it doesn't really show up to your house. And we'll just do that on a continuous loop in production, and then use that as the basis for our monitoring, our performance testing, all the rest of it. Yeah. How do I feel about vendor lock-in? Tricky. I get asked with AWS specifically. Yeah. I don't worry too much about it. I mean, like I say, I'm a recovering .NET developer. So for a long time, my career was entirely tied to the success or failure of Microsoft's ecosystem. And actually, when you're in that ecosystem, it works just fine. And a lot of people outside that ecosystem are like, oh, but vendor lock-in. I'm like, yeah, but it works and it's great. Visual Studio's really good, and like .NET's great. I think the same is true of AWS. Like, they are the market leader. They do have vendor lock-in, but it works really, really well. If they suddenly turned really evil, we'd be scuppered, but then so would half the internet. So I worry about it, but not like, I worry about it less than I worry about climate change. Like, slightly more than road traffic accidents.